Hi everyone. Mitsubishi asked me, Mike, and Edward to do a problem for them. We just got hired by them. So the question is, Mitsubishi just hired us to help with the design of their new line of semi trucks. One of the engineers designed cylindrical tanks for one model of the truck. With their axis horizontal, now he wants to help figuring out how much liquid the tank holds when it is partially or completely full. There is a transparent band the height of the tank so the depth of liquid can be easily seen. The engineer tells you to calibrate the transparent band to calculate volume. He knows that you can use our backgrounds in calculus to convert the height of liquid into the filled volume of the tank. Assume that the cross-sectional radius of the tank is r and its length l and calibrate the band for them. So there's two ways to do this calculation. One, what I am going to do in this video is the calc way of doing it, and what Edward is going to do in his video explanation is the geometry and trig way of doing it. So let's get started. I would write it out for you guys step by step. However, with technology, that's a little hard to do. I don't really have the technology to. I mean, I could, but it wouldn't be the best handwriting. My handwriting's already bad in general. It wouldn't be the most legible handwriting. So I already have it written down. Sorry, I always get these pop-ups on my screen. I don't have the best handwriting. It would be hard. Sorry, I lost my train of thought there. But I'm just gonna show you basically this way. I already wrote it down on a piece of paper. So the first thing we did was draw the picture. So we know that it's a cylinder, and here's negative r, and the height would be h. Here's the height. And we noticed that we had to do the area, we needed the equation of a circle first, which is over here, x squared plus y squared equals r squared. They told us to use r. And also, so now we need it in terms of y because it said the axis is horizontal in the problem, if you remember. So we solved for x and got plus or minus the square root of r squared minus y squared. So what we did from there was we knew we had to find the area. So we had to take the integral, obviously. And to find the bounds, I'm going to go back to this picture, because that was what the picture was mostly for, to help us find the bounds. And as you see, you're going vertical, and you start off with negative r. So that's going to be the bottom bound. It's going to be the very bottom. And we don't know how much is in the tank. So it's negative r plus h. So h could be here, it could be here, it could be here, it could be anywhere. So it's negative r plus h would be the top bound. Then we had to set this part up. So there's two equations right there, technically. There's plus, and then there's another equation, which would be minus. And we had to subtract the bigger one by the smaller one. So we used obviously the positive one minus a negative and then the smaller one. Same equation, just positive and negative. However, we also needed the length. So we had to multiply all that all by L, which we took out of the integral. Technically, L is a constant. We're solving for Y. So R is our constant as well. So let's go down to this step. All we did, so a negative plus a negative equals a positive. You know that. Easy. Everyone knows that. So now we would have this plus that equation. First plus second, which is two of them. So we have a 2 right there as well. So we have 2, and then the square root of r squared minus y squared, and then dy. Now I scroll down a little bit. Let's go up a little. And we notice for this, let's go back to this equation. We know that we have to do trig sub to solve that. And if you notice, that's technically a constant. So that could be a minus y squared. So a squared minus y squared, which we know is the trig substitution identity of sine. So we put y equals sine, and I apologize, I should have put this over there. It doesn't matter. Then we had y over r equals sine of u. And we had the derivative of this one, so it's r cosine u du. And we had u equals the inverse sine of y over r. So if we go down a little more, we're going to set it up. So we're going from here to here. So again, I pulled out that 2 in the next step, just so you know where that 2L comes from. And all we did was plug in this for y right here. So we plugged in r sine u for y. That's it. That's all we did. And then we plugged in the r cosine for dy. So because dy equals that, so we plugged in that. So we plugged in right here. That for y, it's just trig sub. This part for y, and then dy equals that. So we just change it up a little. We don't do anything with this r squared because again, it doesn't have a y. We're not substituting anything in for r. That's a constant. Keeping it right there. Okay, so we came up with this. So y squared, so it's r squared. You square the sine and the r, sine squared, and then move out, and then we still have for dy, r cosine u. So, in the next step, so we're going to go from here to here. All we did was pull out an r squared. So we pulled out this r squared, and we have 1 minus sine squared of u, and then we still have all this out here. And so that's just all we did right there, just 1 minus sine squared. Then in the next step, we changed this right here, the 1 minus sine squared of u. We know that that equals cosine squared u. Same thing, it's just an identity. And we have this r, so we took the square root, and we ended up with r. So we moved the r outside the square root, is basically what I'm telling you guys. And we still left with all that. Then we still have the integral of all this, so we multiplied, we didn't actually take the integral. We took the square root of, let's just forget about the r's for right now, for just a second. We took the square root of cosine, or cosine squared, which gives us cosine. However, now it's multiplied again by another cosine, so we're going to get cosine squared, just without the square root. And now there's 2 r's, so that makes it r squared. So that's how we got from this step to this step. Now, if you look, all we did in this step right here, just from here to here, was just pull out the r squared. Remember, again, it's a constant. I'm emphasizing that because, at least for me, that was the tricky part, knowing that a letter is a constant. So pull it out. So we're left with the integral of cosine squared u du. And we know that cosine squared is an identity, and the identity is 1/2 plus 1/2 cosine 2u du. So just remember, that's all it is. It's an identity. It's the same thing. And in our next step, which is going to be on the next page, I'll go to that in a second. Just know that if you have to write it down, keep track, because I don't have it all written on the next page. But so all we actually took the integral of this. And all we did was right here, we took the integral of 1/2 and we split up the integral. So 1/2, and then we took the integral of 1/2 cosine 2u, just the u sub. And then we came up with this right here. That's the integral of the last. Now, as you know, we are still in terms of u. We don't want it in terms of u. We want it in terms of y. So we're going to have to go back. I'm going to go back to the last page. We're going to go back here, and we're going to go back to over here, all y equals. If you have to write that down, write it down. But pause the video if you have to. But we're right here. That's what we're going to sub in, or using the sub back for. So let me go back now. And when you plug in the y's instead of the u's, we just come up with this. That's what you end up getting. So it looks a lot more complicated now, but that's all right. And then so from this step to this step, we are plugging in the bounds. So just so you guys know, this is, I didn't have enough room. This is one line. So this is this, all this, minus all of this. Subtracted by all that. So just so you guys know. And all we did was plug in the the bounds right here. That's all we did. Not that complicated. So again, this is when we plugged in the top bound, so the negative r plus h for y. And this is when we plugged in the bottom bound, the negative r. And you might be like, how'd you get the -1? Well, when you plug in negative r, you're going to get, look at plug in negative r for y, you're going to get negative r over r, which equals -1. So that's how we got that. And that simplifies as well. And then it all simplifies this. Just plug negative. And that is our final answer once you simplify it. Not the easiest simplification, but it's just an identity. So we knew we had to get rid of the arc signs. It's an identity. So that's how we got to this end. And this is for the circular part. We also have to do the ellipse part, but this is for the circle part. And here is the ellipse part. I gotta go quick because I have a 15-minute max on the free version. So I'm gonna try to go really quick. It's the same exact thing as it was before, but I'm gonna go faster now, so I apologize. So we knew the equation for an ellipse was x squared over a squared plus y squared over b squared equals 1. Again, just like it's the same process last time. Solve for x. We're gonna go down, we're gonna get this. That's the simplification of it. And we're gonna get plus or minus that. So again, two equations. And I knew it right away, just it's gonna be the same thing. So I already took out the 2, just like last time. If you add, it's gonna be a minus, and you're gonna make it a plus, and then you're gonna have 2 of them, so you're gonna pull out the 2L, you have to multiply it all by L, all the same thing. Again, trig sub here. Just like we did last time, but again, it's a sine trig sub. And now again, we're just, for first I crossed out the b squares, and I simplified it. But I also plugged in the sign for y squared. Remember, just y, not the other. A is a constant, b is a constant. And we end up getting, we're gonna pull out the a, and we're gonna take the square root of the a, and we're gonna end up with this right here. Same identity as last time. 1 minus sine squared equals cosine squared, and it's the same type of thing as last time. Cosine, you take the square root of cosine, you're gonna get cosine times cosine. You're gonna get cosine squared. It's the same exact integral. And I'm gonna go to the next page. Before I do, notice I pulled out the AB too. Before I go to the next page, actually. Cosine squared, remember that. The identity. Now here's the identity for it, just like last problem. Boom. I did it the reverse way this time. Sorry if that confuses you. But 1/2 cosine 2u plus 1/2. Again, took the integral of it. Got that right there. Don't forget. The only really difference is we have the A's and B's. Now again, we don't want u's. So we're going back to this. Going back to right here. Again, if you need to write it down, press pause, write it down. So now that I have it back in terms of y, I have to plug in the bounds. So again, plug in the bounds, do negative b plus h, kind of the same thing. Plug them in. Apologize right here. That should be a negative b plus h, not a y. Just notice that. But same concepts. You understand the last one. This one should be very similar. And then we just simplified it for this as our final answer. It's the same thing, basically. So I hope you guys understand how Edward and I solved the problem. Not the easiest problem if you're a beginner in calc, but that's how we did it. And hope I explained it well enough for you guys step by step to understand it.